Welcome to this explainer. Okay, today we're putting on our senior SRE hats. We are going to take those chaotic, scrolling log streams and transform them into actionable metrics using Grafana Loki. Seriously, if you've ever stared at a massive wall of text during a full-blown outage, just trying to figure out exactly how badly things are broken, well, you are in the exact right place.
Let's jump right in. Raw logs are great, right? They're fantastic for context because they tell you exactly what happened. But metric queries, they are what actually measure the severity of an incident. They tell you exactly how bad it is. And today, we're going to learn how to bridge that gap. Here's our game plan. 1. Logs tell, metrics measure. 2. Filters versus metrics. 3. Core metric functions. And 4. Scenario, the error alert.
Starting off with Section 1, Logs tell, metrics measure. Imagine this. Your pager goes off. The alert just says you have 10 errors in the payment service. Well, okay. You're completely lacking context here because if those 10 failures are out of just 50 total requests, that is catastrophic. That's a 20% error rate. But if it's 10 errors out of 50,000 requests, yeah, that might just be normal background noise, you know? Context is literally everything.
And this is exactly why staring at raw counts in a table like this doesn't work. It just doesn't give you the error rate percentage you actually need for threshold-based alerting. You can't just set an alert for 10 errors. You absolutely have to calculate the percentage of failed requests over time to actually understand the severity of what's happening.
Moving right along to Section 2, Filters versus Metrics.
So, LogQL is basically broken down into two main parts. You've got stream selectors and line filter expressions. These are just finding text. It's like finding the needle in the haystack. But then you have metric expressions. These calculate actual values. Instead of finding the needle, they're weighing the entire haystack.
So, what is a LogQL metric query? Well, by wrapping your log queries in metric functions, you derive actual time series insights directly from your existing log streams. The real magic here is that you don't need to go back and rewrite your application code to deploy new Prometheus metrics. Your logs already have the data. You just have to extract it.
All right, Section 3, Core Metric Functions.
By the way, if you want to test these out live, you should totally head over to Grafana Play. Here is how you build that pipeline. You start with count under overtime to get raw counts in a specific window. Then you graduate to rate, which calculates the per-second rate of those entries. And finally, you bring in aggregation operators like SumBy to group those dimensions and see the big picture across multiple services.
Oh, and if you need to calculate latency percentiles or track request sizes, the unwrap expression is going to be your absolute best friend. After parsing your logs, let's say into JSON, unwrap goes in and extracts those hidden numbers, like duration or bytes. Once they're extracted, you can run math operations directly on them. It is super powerful.
Let's put this into practice with Section 4, Scenario, the error alert.
Picture this. It's a Tuesday afternoon and suddenly the pager goes off. Critical. Elevated error rate detected on production API. Okay, deep breath. You open up a dark Grafana Explorer interface, make sure your Loki data source is selected, and you get ready to find the root cause.
We start building our LogQL query right there in the editor. First things first, we use our stream selector to grab that production API server. Then, we apply a really simple line filter, just looking for the word error.
But the result is this completely unreadable wall of raw log text. Sure, it tells us what happened. We see connections refused, we see timeouts, but it doesn't tell us where the spike is actually concentrated. Is the whole system down, or is it just one specific endpoint? To fix this, we need to zoom out. We take our filter and wrap it in a metric function. Specifically, we apply a rate function over a 1-hour interval. This completely transforms our chaotic text into a clean per-second measurement of errors.
Now, take a second to notice the architecture behind what we just did. We filter for the string error before doing any complex parsing or aggregating. This is known as the filter early principle. By eliminating all the non-error logs right off the bat, we drastically reduce the load on the Loki queryers. That's exactly how you make a dashboard panel load lightning fast.
Finally, we need to group this data logically so it actually makes sense. We apply the SumBy operator, grouping by status code and endpoint, and we wrap the entire metric expression in it. This takes all those individual error rates across all our different pods and combines them into really meaningful categories. And just like that, the chaotic log lines completely vanish. In their place is this perfectly clean time series output. We now have a precise numeric value for our error rate over the last hour, perfectly organized by endpoint and HTTP status code. And the best part? Grafana can easily map this data.
Which gives us this, our final dashboard panel. By turning our logs into metrics, we get this incredibly clear visualization that instantly pinpoints the checkout endpoint as the exact source of 85% of our 500 errors. We just went from a panicked, vague pager alert to isolating the actual problem. Using just a few lines of LogQL, how cool is that? As we wrap up this explainer, let's look at how you maintain this kind of efficiency as you scale up. Rule number 1, parse late, filter early. 2, definitely avoid high cardinality labels. Please don't try to index millions of unique user IDs as labels. You will literally crash your system. Extract them at query time instead. Next, if you've got a heavy dashboard that everyone in the company looks at, use Loki recording rules to pre-compute those queries in the background. And finally, unify your logs and metrics workflow.
So, I want to leave you with a somewhat provocative question. Your logs are absolutely full of untapped time series data. So, how much reliability debt is hiding in your unqueried log streams right now? What kind of crazy insights are you going to uncover when you actually start treating your logs as metrics? Thanks for joining this explainer. Now go build some dashboards.